Hello students, welcome to the 8th video of straight lines. In this video we will learn about family of straight lines and concurrent lines. Okay, about concurrent lines, conditions for 3 lines or 4 lines or 5 lines to be concurrent. Okay, first let us learn about family of straight lines. What do we mean by family of straight lines? See, suppose I have a line, let us say this is L1 and it is denoted by A1x plus B1y plus C1 is equal to 0. Okay, let the first line be A1x plus B1y plus C2 is equal to 0, and let us say we have another line, let us say it is L2, and the equation of this second line is A2x plus B2y plus C2 is equal to 0. Okay, we have two straight lines. Let us say this is the point of intersection of these two straight lines, right? The point where the two lines are crossing each other or meeting each other is point of intersection. Okay, now how many straight lines will pass through this point? We will have infinite straight lines. See, these are two intersecting lines, right? So this is point of intersection. From this point of intersection we'll have many straight lines passing, right? We will have infinite straight lines passing through this point. All right, all those straight lines which are passing through this point of intersection are named as family of straight lines. Okay, they are a family because all the straight lines are passing through a fixed point. Okay, point of intersection of these two lines. Alright, I hope you understood what is family of straight lines. See, A1x plus B1y plus C1 is equal to 0 is one straight line, A2x plus B2y plus C2 is equal to 0 is another straight line. Okay, these two straight lines are intersecting at this point, and all the lines that are passing through this point, including these two lines also. Okay, all the lines which are passing through this point of intersection are called as family of straight lines. Okay, let us talk about one straight line which is passing through this. Okay, now let us find the equation of this straight line. Okay, to find the equation of this straight line, all we have to do is write the equation of the first straight line, that is A1x plus B1y plus C1 plus lambda. Lambda is a parameter, it can take any value, lambda, and equation of second line A2x plus B2y plus C2 is equal to 0. This is the equation of the line which is passing through the point of intersection of these two lines. Okay, see, we can write A2x plus B2y plus C2 first. Okay, we can write this here or this here, or we can write lambda here also, it doesn't matter. Okay, in some books lambda 1 and lambda 2 will be given, it is exactly same. Okay, now I hope you understood this. See, we have two straight lines, A1x plus B1y plus C1 is equal to 0, A2x plus B2y plus C2 is equal to 0. Okay, now the point of intersection of this is point, okay, this one. Let us say this is alpha comma beta. Point of intersection of these two straight lines is alpha beta. Okay, now alpha beta should satisfy this equation. In place of x and y, if we substitute alpha beta, it should become 0 because this point is lying on this straight line, right? It should satisfy. So A1 alpha plus B1 beta plus C1 is equal to 0. See, this whole part should be equal to 0, right? In place of x we wrote alpha, in place of y we wrote beta. In the same way, alpha beta should also satisfy this, isn't it? So A2 alpha plus B2 beta plus C2 will be equal to 0. Okay, now let us check whether alpha beta will satisfy this equation or not. Okay, if we substitute alpha beta in this, we should get equal to 0. Okay, only then this alpha beta will lie on this. We are proving that the equation of a straight line which is passing through the point of intersection of these two straight lines will be like this. Okay, yes, let us substitute that. See, let us substitute alpha beta here. So what do we have? It will be a1 alpha plus b1 beta plus c1 plus lambda a2 alpha plus b2 beta plus c2 is equal to 0. But see, a1 alpha plus b1 beta plus c1 is 0, right? This whole part will become 0. So we'll have 0 plus lambda. This is also equal to 0, right? 0. So lambda plus 0 plus lambda 0, it is equal to 0. Okay, it is satisfying, which means alpha beta will lie on the straight line. Okay, in other words, this straight line is passing through alpha beta, isn't it? This will also be a straight line. No matter what value of lambda we put here, lambda is a parameter. It can take any value, negative values, positive values, fractions, okay, anything. No matter what value we put here in place of alpha, in place of lambda, we'll have a linear equation. We'll have equation of a straight line. Okay, we'll do few problems now. I hope the concept is clear. Okay, let us solve this problem. Find equation of straight line passing through the point of intersection of the lines. Okay, two lines are given. Let us draw the diagram. See, let us say this is the first line, x plus y plus 1 equal to 0, and this is the second line, 2x minus y plus 5 is equal to 0. Okay, always draw rough diagrams. Now what is given? We need to find the equation of straight line that is passing through the point of intersection of these two straight lines. See, these two straight lines are intersecting at this point. Okay, we need to find the equation of a straight line which is passing through this point and also containing 5 comma minus 2. Okay, so this is the straight line that will pass through this, right? So let us say there is a point 5 comma minus 2 on this point. We need to find the equation of this line. Okay, I hope the question is clear. Find the equation of a straight line passing through the point of intersection of these two straight lines and which also contains 5 comma minus 2. Okay, see, there are many methods of solving this problem. In your syllabus, you can do this in two methods. Okay, we'll do those two methods. Alright, now, just now we have studied that equation of this straight line will look like this, right? a1x plus b1y plus c1 plus lambda a2x plus b2y plus c2 is equal to 0. Okay, let us substitute this. See, a1x plus b1y plus c1 is this one. You can take this also, 2x minus y plus 5 also. Okay, it is up to us. Let us write this, x plus y plus 1 plus lambda, this one, 2x minus y plus 5 is equal to 0. Okay, now to find the value of lambda, what should we do? See, this straight line is this straight line and it is passing through 5 comma minus 2. So if you substitute 5 comma minus 2 in place of x and y, we will get the value of lambda, right? Because see, this is the straight line which is passing through 5 comma minus 2 also, right? Okay, so if we substitute 5 comma minus 2 here in place of x and in place of y, if we substitute 5 comma minus 2, we'll get the value of lambda. Let us do that. So 5, y is how much? Minus 2. Minus 2 plus 1 plus lambda. This will be 2 into 5. Minus of minus 2 will become plus 2. Plus 5 is equal to 0. So 5 minus 2 is 3. 3 plus 1 is 4. So this is 4 plus lambda. 10. 2 5s are 10. And 7. 17 is equal to 0. So lambda is equal to minus 4 divided by 17. Minus 4, plus 4 will come this side, it will become minus 4, and 17 will go on the other side, it will divide. So value of lambda is equal to how much? Minus 4 by 17. Now we need to substitute the value of lambda in this equation. Okay, let us do that. See, we had x plus y plus 1 plus lambda here, right? Lambda 2x minus y plus 5 is equal to 0. So in place of lambda, let us substitute minus 4 by 17. Okay, multiply both sides by 17. So this will become 17 x plus y plus 1 minus, if we multiply by 17, this 17, that 17 will get cancelled. We'll have 4 into this equation equal to 0. We can simplify and it will be a linear equation, right? We'll get the equation of this straight line. Let us check. 17x plus 17y plus 17 minus 8x plus 4y minus 20 is equal to 0. Okay. 17x and 8x is how much? 9x. This 17x and 4x will be 21y. Sorry, y, right? 17 minus 20 is left. So minus 3 is equal to 0. Okay. Alright. Is everything okay? 17 minus 8 is 9, 17 and 4. We added 21, 17 minus 3. Okay. If we divide both sides by 3, what do we get? We get 3x plus 7y minus 1 is equal to 0. So this is the equation of this straight line. 3x plus 7y minus 1 is equal to 0. If you want to verify whether our equation is correct or not, one thing we can do is we can substitute the value of 5 comma minus 2 in this. Let us check. 3 into 5 plus 7 into minus 2 minus 1. It should give us 0, right? So this is 15 minus 14 minus 1. So yes, 15 minus 15 is equal to 0. Let me just check whether this is visible in the video or not. Oh, even I am not able to see, right? Okay. Anyways, let's hope this is visible. Alright. So see, this is one method of solving. There is another method. We will get the same answer. 3x plus 7y minus 1. Okay, what is that method? Let us learn that. See, we know how to find the value of this point. Okay. We have two lines. Okay, x plus y plus 1 equal to 0 and 2x minus y plus 5 is equal to 0. We know how to find the point of intersection of these two lines. Okay, by using elimination method. Right, 2x, let us simplify these two lines. X plus y plus 1 equal to 0. So this 2 will get cancelled. We'll have 3x plus 6 is equal to 0 and x value will be equal to minus 2. 6 goes on the other side, minus 6 divided by 3 is minus 2. Okay, if we substitute minus 2 in one of these equations here or here, we'll get the value of x. Let us substitute it here. X plus y plus 1 equal to 0. So x is how much? Minus 2. So minus 2 plus y plus 1 equal to 0. Y will be equal to plus 1 if you simplify. So minus 2 comma 1 is the point and there is one more point given, 5 comma minus 2. Now see, we have 2 points. We need to find the equation of a straight line passing through 2 points. We can use 2-point form, which we studied in the previous videos, right? We can use 2-point form. We can find the slope or use point slope form also, right? So let us simplify that. Okay. See, let us find the slope y minus y1. Let us use this x minus x1 point slope form. So if you take this as x1 y1, you can take this as x1 y1 also, right? So y minus of minus, it is plus 2 m. M value is y2 minus y1. y2 minus y1. So 1 minus of minus plus 3 minus 2 minus 5. X minus x1. Okay. So this is y plus 2, 3 by minus 7, x minus 5. So minus 7y minus 14 is equal to 3x minus 15. Okay. These two terms, let us send it on the other side. We'll have plus 7y plus 14 is equal to 0 or 3x plus 7y minus 1 is equal to 0. 3x plus 7y minus 1 is equal to 0. Okay. I hope you understood this problem and you understood the concept behind the family of straight lines. It is not confusing at all. Perhaps it is one of the most easiest concepts in straight lines. Okay. We'll do few more problems. Okay. Transform the equation in L1 plus lambda L2 is equal to 0 form. We need to transform this. We are given two questions. We need to transform this in L1 plus lambda L2 is equal to 0 form and find the point of concurrency. Okay. Alright. Now let us take the first one. I'll solve the first one in the video. You please solve the second one. Okay. Alright. So what do we have? Let us multiply. We'll have 2x plus 5kx. We are multiplying x with 2 and x with 5x. And here 3y minus 3 2s are 6k, and here y 6ky plus 2 minus k is equal to 0. Okay, see here lambda is the parameter, right? So here the parameter is k. Alright, okay, so x values. So we have 2x. See, the terms which are not having k values, I am writing it one side. So this is 2x, this is not having k, so this is minus 3y and plus 2. Okay, plus 5kx, this term minus 6ky minus k is equal to 0. So all 6 terms we wrote. Can we take k common from this? Yes. So it is like this, plus k multiplied by 5x minus 6y minus 1 is equal to 0. So see, this is of the form L1 plus lambda L2 is equal to 0. Okay, so this is the first line, this is the second line. What was the concept? See, two lines, this is first line, this is second line. Okay, we need to find the point of intersection of these two. That means if we simplify these two, 2x minus 3y plus 2 and 5x minus 6y minus 1, will get this point, isn't it? Let us simplify that. So what is L1? 2x minus 3y plus 2 equal to 0 and 5x minus 6y minus 1 equal to 0. Let us use elimination method. Let us multiply this equation with 5 and this equation with 2. 5 2s are 10, right? So this is 10x minus 15y plus 10 is equal to 0, and this is 10x minus 12y minus 2 is equal to 0. So change the signs when we subtract. Minus 3y plus 12 is equal to 0. 12 goes on the other side, becomes minus 12, right? So this will be minus 12. So y will be equal to 4. Minus 12 divided by minus 3 will be equal to plus 4. Now let us substitute y is equal to 4 in one of these equations. Let us substitute it in this. 2x minus 3y plus 2 is equal to 0. 2x minus 3 into 4 plus 2 is equal to 0. So this is 2x minus 12 plus 2 is equal to 0. So this will be 2x minus 10 is equal to 0. 10 goes on the other side, becomes plus. So x will be equal to 10 by 2. It will be equal to 5. So the point of intersection of these two straight lines is 5, 4. Okay. I hope this is clear. Now I am expecting you to solve this problem. Okay. Okay. This is an important problem. If 3a plus 2b plus 4c is equal to 0, this is the condition given. We should prove that. Show that the equation ax plus by plus c is equal to 0 represents a family of concurrent lines. What are concurrent lines? Concurrent lines are lines which pass through a fixed point. Okay. So how many points will pass through a point? We will have infinite lines passing through a point. So all those lines are called as concurrent lines. Okay. Okay. See, this is the condition given, and we need to show that equation ax plus by plus c is equal to 0 represents the family of concurrent lines, and we need to find the point of concurrency also. Okay, what should we do here? See, we can find the value of c from this given condition and substitute it here. See, we have 3a plus 2b plus 4c is equal to 0. 4c will be equal to minus 3a minus 2b, right? And this 4 goes on the other side. It will be c is equal to minus 3a minus 2b divided by 4. So in place of this c, we can substitute this value. ax plus by plus c is equal to 0. So ax plus by, in place of c, let us substitute this, divided by 4 equal to 0. Okay. If you take minus common, write minus here, so it will be like this, right? Okay. Now, this is one method. If you simplify this, you will get the value of, see, you will get the equation. 4 goes here, so it will be 4ax plus 4by minus 3a minus 2b is equal to 0. We multiplied by 4 on both sides. Okay. We can do this, or see, we can simplify. See, the best thing here is, wait, See, a and b are variables, right? Are parameters. So what can we do? See, this is 4x. Let us take a common here. So this will be, this is one term and minus 3 will be left here, right? This is 1. And let us take b common from this. So it will be 4y minus 2 is equal to 0. Okay. Now, if you divide both sides by a, so what do we have? We have 4x minus 3 plus b by a divided by 4y minus 2 is equal to 0. Now, isn't it of the form L1 plus lambda L2 is equal to 0? This is first line, this is second line. So, first line is 4x minus 3 is equal to 0 and the second line is 4y minus 2 is equal to 0. So, from here if you find the value of x, it will be 3 by 4 and y will be equal to 1 by 2. 2 by 4 will be equal to 1 by 2. So, the point of intersection is what? 3 by 4 comma 1 by 2. Okay. This is one method of solving this. But another, the most easiest method is, see, we got 3 by 4 and 1 by 2, right? So let us write the answer here. 3 by 4 and 1 by 2. Okay, see, easiest method will do is 3x plus 2b plus 4 equal to 0. Sorry, 4c is equal to 0. Okay, we'll divide both sides by 4 here. Okay, so this will be 3 by 4a plus 1 by 2b plus c is equal to 0, right? So now see, this is like this. It is like ax plus by plus c is equal to 0. Okay. So what is the value of x and y? X value is 3 by 4, y value is 1 by 2. See, ax. So we have a. What is x value? 3 by 4. What is b value? 1 by 2. X value is 3 by 4, b value is 1 by 2. We'll get the point of intersection at 3 by 4 comma 1 by 2 is the point of intersection, because see, x is equal to 3 by 4 and y is equal to 1 by 2 is satisfying this condition, which means this line should pass through 3 by 4 comma 1 by 2 only, right? So we can solve this problem in two methods. This is one method and this is the second method. Okay, let us learn about concurrent lines now. What are concurrent lines? The lines which pass through a fixed point. All the straight lines that pass through a fixed point. Okay, let us say this point is 2 comma minus 3. For example, let us say this is point 2 comma minus 3 and all the points that pass through this 2 comma minus 3 are called as concurrent lines. Okay, how many lines will pass through 2 comma minus 3? Infinite points, infinite lines, right? So all the straight lines that pass through a fixed point are called as concurrent lines. Okay, now we'll learn what will be the condition of the concurrent lines. Let us say we have three lines. Let us say the first line is a1x plus b1y plus c1 is equal to 0 and the second line is a2x plus b2y plus c2 is equal to 0 and the third line is this. Okay, now the condition is we need to find the determinant and it will be equal to 0. See, write the coefficients a1, a2, a3, b1, b2, b3, c1, c2, c3. Okay, this is the sufficient condition to prove that these 3 points, these 3 straight lines are concurrent. If the determinant is equal to 0, these 3 straight lines will be concurrent, which means they will pass through a fixed point. Okay, this is one method of proving that the 3 lines are concurrent. Another method is you can take any 2 lines. You can take this line and simplify find the point of intersection of these 2 lines and substitute that point in the third line. Okay, we'll do problems like that also. We can take the first 2 lines, you can take these 2 lines, or you can take the first and the third line. Find point of intersection. See, let us say this is L1 and this is L2 and this is L3. So this is L1 and L2. So see, point of intersection of these 2 lines is this, right? Okay, now we have simplified this 2. We have simplified these two lines and we got the value of x and y. That x and y will be the point of intersection, right? And if we substitute this point xy in the third equation, it should satisfy, right? Because the third line L3 will be passing through this point of intersection only, right? So this point will also lie on this third line, right? Which means the point of intersection of these two lines, if we substitute in the third line, it should satisfy the condition, right? Okay, that is one method and this is one method. So how can we write this? See, this is A1. Now these two should be multiplied, B2C3 minus C2B3, and this is minus. I hope from matrices you know how to find the determinant. B1, this is A2C3 minus A3C2 plus C1, this two, right? A2C3 minus C2, A3 is equal to 0. This is the condition for the three lines to be concurrent. Okay, I hope you understood the concept. We'll do few problems. Okay, show that the lines are concurrent. We are given three lines. We need to prove, or we need to show that these three lines are concurrent and also find the point of concurrency. Okay, see, we need to prove that if this is the first line and this is the second line, third line is this, right? Concurrent lines. What are concurrent lines? Lines that pass through a fixed point. We need to prove that these three straight lines are concurrent. What is the procedure? See, we need to solve any two lines. We need to find the value of x and y using these two lines or these two lines or first and the third line. We'll get point of intersection of two straight lines, right? That point should be substituted in the third straight line. Alright, we can solve this two. We'll get the value of x and y. That value of x and y, if we substitute it here, it will be equal to 0. Okay, we can say that the three straight lines are concurrent to each other. You find the determinant of this, it will be equal to 0 only. Okay, see, 2x plus y minus 3 is equal to 0, 3x plus 2y minus 2 is equal to 0, 2x minus 3y minus 23 is equal to 0. If you find the determinant 2, 3, 2 coefficients, right? This is plus 1, plus 2, minus 3, minus 3, minus 2, minus 23. You find the determinant, it will be equal to 0. Okay. Now, we can prove that. That way we can prove that these three straight lines are concurrent to each other. But we'll use one more, another method, which is very useful in straight lines. We'll simplify these two straight lines and whatever point we are getting, we will substitute it in the third. Okay. So let us get the value of x and y by simplifying this. Multiply this whole equation by 3, this whole equation by 2, so that the coefficients of x will become same. So this is 6x plus 3y minus 9 is equal to 0. 6x plus 4y minus 4 is equal to 0. Minus minus plus. So this 2 will get cancelled. Minus y minus 5 equal to 0. So y will be equal to minus 5. Okay. Now if you substitute y is equal to minus 5 either in this or in this, we'll get the value of x. Okay. Let us substitute it in 2x minus 2x plus y minus 3 is equal to 0. 2x, y value is minus 5, we got minus 3 is equal to 0. So it is 2x is equal to 8. Minus 5 minus 3 is minus 8. Minus 8 goes on the other side, becomes plus 8. 8 by 2 is equal to 4. Okay. So we got the point of intersection 4 comma minus 5. Now this 4 comma minus 5, if we substitute in the third equation, it should satisfy. Let us check. 2x minus 3y minus 23 should be equal to 0. So 2, this is 4, 3, y value is minus, right? So 10 plus, sorry, this is 8, right? 2 4s are 8 and this is 15 minus 23. See, this is 23 minus 23, it is equal to 0. Okay. So 4 comma minus 5 is lying on this straight line, which means this straight line is passing through this point, right? In another words, yes. So these three straight lines, given three straight lines, are concurrent. Alright. Okay. Find the value of P if the following lines are concurrent. We are given 3 bits. Okay. These are the 3 lines and it is clearly given that the lines are concurrent, which means the lines are like this, right? Okay. Let us say this is 3x plus 4y is equal to 5, 2x plus 3y is equal to 4, and this is px plus 4y is equal to 6. These are the equations of 3 straight lines given. We need to find the value of p. See here, like in the previous problem, we need to simplify this 2 and we'll get the value of x and y. That value of x and y, if we substitute it in the third equation, it should satisfy. So that will be our approach. Okay, we'll find the value of p. Let us do that. I'm going to do the first problem. You please try the second and the third ones. So 3x plus 4y minus 5 is equal to 0. This 5 I am writing this side. 2x plus 3y minus 4 equal to 0. Let us multiply this equation with 2 and this equation with 3. So it is 6x plus 8y minus 10 equal to 0, and this is 6x plus 9y minus 12 equal to 0. Signs will change. X terms got cancelled, right? So this is minus y minus, plus 2. Minus 10 plus 12, right? So y value will be equal to 2. Okay. Now let us substitute y is equal to 2 in either one of these equations, right? Okay. Let us substitute it here. 3x plus 4 into 2 is equal to 5. 3x plus 8 is equal to 5. 8 goes on the other side, becomes minus. So 5 minus 8 will be minus 3. So x value will be minus 1. So minus 1 and 2. Let us substitute that minus 1 and 2 in the third equation. Px plus 4y is equal to 6. So p, x value is minus 1 plus 4 into 2 is equal to 6. Minus p plus 8 is equal to 6. Minus p, this 8 goes on the other side, minus 2. So value of p is equal to how much? It is equal to 2. Okay. So please solve the second and the third problems.